Welcome back to my class, Easy Maths by Sukumar. Today we are going to solve the remaining sums in this exercise 7.1. Fifth sum is like this. In a classroom, 4 friends are seated at the points A, B, C, D. A, B, C, D. Okay. As shown in figure, Jarina and Funny walk into the class, and after observing for a few minutes, Jarina asks Funny, "Don't you think ABCD is a square?" Funny disagrees. Using distance formula, find which of them is correct. Okay, I hope you understand this question here. There are two persons, one is Jarina and Funny. Okay, see here, that Jarina asks Funny, "Don't you think ABCD is a square?" But Funny disagrees. Okay, we will what? Verify that this ABCD is a square or not. That means who is correct here? That means Jarina or Funny. The Jarina says this ABCD is a square. Okay, let us find. First we will find the coordinates of A, B, C, D here. So the coordinates of A here is 2, 4. This is 2, 4, and the coordinates of B are, okay, this is some 6, 7, and the coordinates of C are, this is 9, 4. 9, 4. Let us verify with this question in the textbook also, right? Here, what about D students here? 6, 1. This is 6, 1. Let me verify here in this figure. Okay, look, here the capital A is at 3, 4. Capital A is at 3, 4, not at 2, 4. This is 3, 4. And capital B here it is at B. Girl B is, the position of the girl B is 6, 7, and capital C, the third girl, where he is sitting at 9, 4. Okay, good. And the capital D, the position of the fourth girl, is at 6, 1. Okay. Let us find the distance between A, B, C, D. A, B, B, C, C, D, and A, D. Okay. So first A, B. The distance between 2 points. The distance between 2 points. What is the formula, students? The distance between 2 points is root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. Here this A is here 3, 4 and B is 6, 7. So the distance between A and B, that is AB, is equal to 6 minus 3 whole square plus 7 minus 4 whole square. So what is 6 minus 3? 3 square plus 7 minus 4 is also 3 square. That means 9 plus 9, that is root 18. Root 18 means that is 9 into 2. So this is equal to 3 into root 2. So the distance between A and B is 3 root 2 units. This is AB. Okay. Let us find the distance between B and C. That means BC. What is B here? 6, 7 and C is 9, 4. So BC is equal to root of 9 minus 6 whole square plus 4 minus 7 whole square. X2 minus X1 plus Y2 minus Y1. Y2 is 4, Y1 is 7. So this is equal to 3 square plus minus 3 whole square. So again 9 plus 9, this is also 3 root 2. Okay. Now let us find what is the next one. AB is over, BC is over. Next one is CD. C is 9, 4 and D is 6, 1. So CD is equal to root of again 9 minus 6 whole square plus 4 minus 1 whole square. This is 3 square plus 3 square. This is 9 plus 9, that is equal to root 18. Root 18 means 3 root 2. 3 times root 2. Okay. And one more thing here, the last one is AD. What is A here? 3 comma 4 and D is 6 comma 1. So AD is equal to root of 6 minus 3 whole square plus 1 minus 4 whole square. That is equal to 3 square plus 3 square. 9 plus 9 is equal to root 18. This is also 3 root 2 units. Okay. So what do you observe, students, here? All the sides are equal. AB, BC, CD and AD are equal. Okay. So can you come to a conclusion here? No. Since all the sides are equal, even in rhombus also. For square also all the sides are equal. But what is the difference between rhombus and a square? In a square the diagonals are equal, but in the rhombus the diagonals bisect each other at right angles. Okay. So let us verify now. Here these two are diagonals, BD and AC are diagonals. Let us verify the lengths of the diagonals AC and BD. Okay, so what is A here? A is 3 comma 4 and C is some 9 comma 4. AC, this is AC. Similarly, we will find the distance between B and D, another length of the diagonal BD. Okay, so here this AC is equal to root of 9 minus 3 whole square plus 4 minus 4 whole square. Okay. See, my dear students, 9 minus 3 whole square is 6 square. 4 minus 4 whole square is 0. So that is equal to 6. So AC is equal to 6 units. Now coming to what? Here, the another length of the diagonal BD. So the B is here. The coordinates of B, the vertex of B is 6 comma 7 and D is 6 comma 1. 6 comma 7, 6 comma 1, right. So this BD is equal to root of 6 minus 6 whole square plus 1 minus 7 whole square. That means this is 0 plus 1 minus 7 is minus 6 whole square, that is 36, that is equal to 6. So what do you observe here? This AC and BD are equal. That means the diagonals are equal. The diagonals are equal. As I told you, students, the difference between rhombus and square is the diagonals are equal in a square, but coming to the rhombus, the diagonals bisect each other at right angles. So here all the four sides are equal. All the four sides, that means AB, BC, CD, AD. All the four sides, the lengths of the four sides are equal. And another thing what we proved here, the diagonals, the lengths of the diagonals are also equal. Therefore, our conclusion here is ABCD is a square. ABCD is a square. All sides are equal and the diagonals are also equal. So who is correct here? Yeah, here Jarina is saying correct. Okay. I hope you understand this question, students. Please write down. Coming to the sixth question, this exercise 7.1. Okay. Show that the following points form an equilateral triangle. Here capital A, capital B, capital C. That means the three vertices are given. We have to prove that these three vertices are the vertices of an equilateral triangle. A, B, C. A is A comma 0, B is minus A comma 0 and C is 0 comma A root 3. Okay. These are the three vertices of an equilateral triangle. We have to prove that these are the vertices of an equilateral triangle. Okay. See, my dear students, as I told you in the previous video, equilateral triangle means all the three sides are equal. All the lengths of the three sides are equal. That means AB, BC and AC. All the lengths of the three sides are equal. Okay. First we will find AB here. So distance formula. Again we use distance formula. So what is distance between 2 points distance between 2 points is root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the distance between 2 points. Let us find the distance between A and B here. So what is A? A comma 0 and B is minus A comma 0. That means AB is equal to, can you see the board? Right. AB is equal to root of x2 x1 y2 y1. That means minus A whole square plus 0 minus 0. That means 0 only. 0 minus 0 0 only. That means here minus A is minus 2A whole square plus 0. So this is under root. So minus 2A whole square is 4A square. That is equal to root of 4 is, the square root of 4 is 2 and A square is A. That means this is 2A units. That means AB is equal to 2A units. What about BC? The coordinates of B are minus A comma 0 and C are 0 comma A root 3. So this BC is equal to square root of 0 minus of minus A. That means 0 plus A whole square plus here A root 3 minus 0 whole square. So this is 0 plus A is A. So that is A square. Here square is there. A square plus here A root 3 minus 0 is A root 3 only. So that is A root 3 whole square means A square. Square and root cancel. So this is equal to just 3A square. Okay. I will write here. A root 3 whole square means this square will be applicable for both A and root 3. So that means A square into root 3 whole square. So this is A square. Square and root get cancelled. That is 3. That means 3A square. So that means A root 3 whole square is 3A square. Okay students. Now what is 3A square plus A square? That is equal to 4A square. This is equal to root of 4A square. So like previous, 4A square means it is also equal to 2A. So this BC is equal to 2A units. And the third one is here. We have to find the length of the third side AC. So what is A here? This is small a comma 0 and C is 0 comma A root 3. 0 comma A root 3. So again we use the distance formula. That is what? Root of x2 minus x1 whole square plus y2 minus y1 whole square. So here this is 0 minus A whole square plus A root 3 minus 0 whole square. So again this 0 minus A is minus A. Minus A whole square is A square plus here A root 3 minus 0 means again 3A square. This is also 3A square. Like this. A root 3 minus 0 is 3A square. So 3A square plus A square is root of 4A square. So this AC is also equal to 2A. So my dear students, what you observe here? The length of AB, BC and AC. AB is 2A, BC is 2A, AC is also 2A units. Therefore, our conclusion here is AB, BC, CA or AC all are equal. Therefore, triangle ABC is an equilateral triangle. This is an equilateral triangle. This is an equilateral triangle. Okay students, I hope you understand this question. Okay, coming to the 8th question in this exercise 7.1. Show that the points minus 4 comma minus 7, minus 1 comma 2, 8 comma 5 and 5 comma minus 4 taken in order are the vertices of a rhombus and find its area. Okay, let us draw a rhombus here. See, this is a rhombus. ABCD is a rhombus. Here what are the vertices of the rhombus in order? -4 comma -7, and B is -1 comma 2, and C is 8 comma 5, and D is 5 comma -4. Okay, here the 4 vertices of a rhombus are given. They are in order. Okay, order is important. Now let us prove that this ABCD is a rhombus. See, my dear students, how do you prove that the ABCD is a rhombus? I already explained about the difference between rhombus and a square. In a rhombus, the diagonals are bisect to each other at right angles. Here the diagonals are not equal, but coming to this square, the diagonals are equal. That means AC and BD are equal. Anyway, we have to find the lengths of the diagonals AC and BD. Okay. See, my dear students, here first we will find AB first. What is A? -4 comma -7, and B is -1 comma 2. So AB is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. This is x1 y1 x2 y2. So here this x2 minus x1 means -1 minus of, here -4 is there. So in the formula itself minus is there. Again here in the x1 place -4 is there. So this minus into minus plus 4 whole square. Okay, similarly 2 minus of, here also minus is there. So minus into minus plus 7 whole square. So this is what? -1 plus 4 is 3 square. 2 plus 7 is 9 square under root. Okay, 3 square is 9. 9 square is 81. This is equal to root 90. Root 90. Okay, what next, students? Here AB is over. Now BC. What is B here? B is -1 comma 2, and C is 8 comma 5. Let us find the distance between what? B and C here. So BC is equal to, again we use the distance formula. So that means 8 minus of minus here, this is plus 1 whole square plus 5 minus 2 whole square. So that means 8 plus 1 is 9 square plus 5 minus 2 is 3 square. That means 9 square is 81 and 3 square is 9. This is also equal to root 90. Okay. So here this AB, BC, both are equal to root 90, and another one is there, DC and AD. D is, what are the vertex of D? 5 comma -4, and C is some 8 comma 5. So DC is equal to root of 8 minus 5 whole square plus 5. Here minus is there. Formula, in the formula also minus is there. So this minus plus 4 whole square. So 8 minus 5 is again 3 square plus 5 plus 4 is 9 square. Okay, 3 square is 9. 9 square is 81. So this is also 81 plus 9 is root 90. So this DC is also equal to root of 90. Can you see the board here, students? Okay. Now we already find AB, BC, CD. Now the last one is AD. So what is A? -4 -7, and D is 5 comma -4. So AD is equal to square root of 5 x2 minus x1. x1 is -4. So minus into minus plus 4 whole square. Similarly, -4 minus into this minus plus 7 whole square. So this is equal to 9 square minus 4 plus 7 is 3 square. That is 81 plus 9. This is also equal to root 90. So my dear students, what do you observe here? All these four sides are equal. AB is root of 90, BC is also root 90, and DC, this distance also root 90, and the last one is AD is also root 90 here. This AD is also root 90. Therefore, AB is equal to BC is equal to CD is equal to AD. Okay, let us we have to differentiate between what? The square and a rhombus. Okay, that means we should find the lengths of the diagonals. What is A here? AC and BD. A is -4 comma -7 and C is 8 comma 5. So AC is equal to 8. This minus is there. X2 minus of X1 means -4, that is 8 plus 4 whole square. Similarly 5 minus of minus plus 7 whole square. So 8 plus 4 is 12 square plus 5 plus 7 is also 12 square. So here it is 12 square plus 12 square, that is 144 plus 144, that is 288. So AC is equal to 2 times 144. This 288 can be written as 2 times 144. So this is equal to under root, this is equal to 12 times root 2. So the length of the diagonal AC is 12 times root 2. Similarly, let us find the distance between B and D. So what is B, students? -1 comma 2 and D is 5 comma -4. This D is 5 comma -4. So BD is equal to square root of 5 plus 1 whole square plus -4 minus 2 whole square. So what about this 5 plus 1? 6 square. So 6 square plus -4 minus 2 is also again -6 whole square. That is 36 plus 36, that is root 72. So this BD is equal to 2 times 36. Am I right? Okay. So this is equal to 6 into root 2. The square root of 36 is 6. So 6 times root 2. Okay. So my dear students, the lengths of the diagonals AC and BD are not equal. AC is not equal to BD. Therefore, this ABCD is A. AC is not equal to BD. Therefore, ABCD is a rhombus. Is a rhombus. Okay. If the AC and BD are equal, then it is a square. Okay. Now, my dear students, we have to find the area also here. Find its area. Actually, what is the area of a rhombus? Half into D1, D2. D1 and D2 are the diagonals. The diagonals of a rhombus. Here the diagonals are AC and BD. Half into AC into BD. So this is equal to half into, what is the length of AC here? This is somewhere, right? Yeah, this is 12 root 2 into BD is what? 6 into root 2. Okay. So here this 2 in 12, 6 times. So 6 into 6 is 36. Root 2 into root 2 is 2. So 36 2s are 72. That means the area of this rhombus is 72 square units. This is 72 square units. Coming to the 9th question here. Name the type of quadrilateral. Actually here there are 3 sums given. Just I will teach you the first sum. The remaining sums you can do on your own, right? See my dear students, here we have to name the type of a quadrilateral. Before we get into this sum, let me revise the properties of a quadrilaterals. That means parallelogram type and non-parallelogram. Parallelogram, non-parallelogram. See, in the parallelogram type, what are the types again? Here the first one is parallelogram. Second one is rhombus. Third one is rectangle. And fourth one is square. Just we recall the properties. We already learned these properties in the class 9, class 8, class 7 also. Okay. See parallelogram. Parallelogram means the both pairs of opposite sides are parallel is called a parallelogram. See, this definition is applicable for all the four types here. These are the family members of the parallelogram. Parallelogram family members. So parallelogram is both pairs of opposite sides are parallel is called a parallelogram. Here the first property of a parallelogram is opposite sides are equal, opposite angles are also equal. Opposite sides are equal, opposite angles are equal. And the third property is the diagonals bisect each other. The diagonals bisect each other. And fourth property is each diagonal divides the parallelogram into two congruent triangles. Okay, so these are the four properties of a parallelogram. These four properties are also applicable for rhombus, rectangle and square. But there are some special properties in rhombus, rectangle and square. See my dear students, in a parallelogram only opposite sides are equal. Even the rectangle also opposite sides are equal here and here. Opposite sides are equal. Parallelogram and rectangle. But what is the difference between a parallelogram and rectangle? In a parallelogram, the diagonals are bisect each other. Bisect each other. That means, suppose this ABCD is a parallelogram means, here this ABCD is a parallelogram means, diagonals bisect each other means, the diagonal AC and BD are the two diagonals here. So here the length of AO and CO are equal, even BO and OD are equal. That means the midpoint of AC and the midpoint of BD are equal. In a parallelogram, diagonals bisect each other means the midpoint of AC and the midpoint of BD are equal. That is the main property in a parallelogram. So all these properties are same even for rhombus, rectangle and square. But what is the difference between parallelogram and rectangle? Here opposite sides are equal, even in rectangle also opposite sides are equal. Here the diagonals are equal in a rectangle. The diagonals are equal in a rectangle. Since it is our board, whiteboard is a rectangle, see these diagonals are equal. This means these two lengths. These are diagonals, AC and BD. This AC and BD are the diagonals. They are equal in a rectangle. But coming to the parallelogram, the diagonals are bisect each other. They are not equal. The diagonals are not equal in a parallelogram. Okay. The diagonals are equal in a rectangle. I hope you understand these two properties. One side parallelogram and another side is rectangle. In a parallelogram, opposite sides are equal. Even here also the opposite sides are equal. Here the diagonals bisect each other. Here also the diagonals bisect each other. And here in the parallelogram, just the diagonals are bisect each other. But here there is an additional property. What is that property? The diagonals are equal in a rectangle. Okay. That means we have to prove that AC and BD are equal. So I already explained that diagonals bisect each other means the midpoint of AC is equal to the midpoint of BD. That means AO is equal to OC, BO is equal to OD. That means O is the midpoint of AC and O is the midpoint of BD. Okay. So I already explained about this parallelogram and rectangle. Okay. And what is next here, students? Rhombus and a square. In a rhombus and a square, all the four sides are equal. In the rhombus and in the square, all the four sides are equal. Here also all the four sides are equal. See, in the rhombus, the diagonals bisect each other at right angles. That means here this AC and BD, if ABCD is a rhombus means this AC and BD are perpendicular to each other. This length of, AC and BD are perpendicular to each other. So this is about rhombus. And coming to the square here, the diagonals are perpendicular to each other and they are also equal. In the square, the diagonals are equal at right angles. Okay, so that means in a square, the diagonals are equal and they are perpendicular to each other. So this is a special case in a square. Okay, students. See, my dear students, so the diagonals are equal in a rectangle and a square. But coming to the parallelogram, the diagonals just bisect each other. But in the rhombus, the diagonals bisect each other at right angles. Even in the square also, the diagonals bisect each other at right angles. And additional property here in the square is the diagonals are equal. So based on these properties, my dear students, we will what? Solve this ninth set. So before we what? Solve this ninth question, there are 3 more bits in this ninth set. We must learn the properties of a quadrilateral. That means parallelogram, rhombus, rectangle and a square. Okay. See, let us take the first question here. -1, -2, 1, 0, -1, 2, -3, 0. So let it A, this is B, C and this is D. Okay, let us find AB first. AB. That means A is -1, -2 and B is 1, 0. So AB is equal to root of 1 minus of minus, that is 1 plus 1 whole square, and 0 minus of minus, that is plus 2 whole square, 0 plus 2 whole square. So this is equal to 1 plus 1 is 2 square, 0 plus 2 is also 2 square. This is equal to 4 plus 4, that is root 8, or this 4 plus 4 can be written as 2 times 4, root of 2 times 4. So this AB is equal to 2 what? 2 into root 2. So what is AB, students, here? In this quadrilateral ABCD, so this AB is 2 root 2. Similarly, we will find BC also. What is B here? 1, 0 and C is -1, 2. So this BC is equal to square root of -1. Here -1 whole square plus 2 minus 0 whole square. -1 is -2 whole square, again plus 2 square under root. So -2 whole square is 4, 2 square is also 4. That means this is equal to 2 root 2, like this. 4 plus 4 is 2 root 2. So BC is also 2 root 2. And what next? AB is over, BC is over. Next one is DC. D is or CD. C is -1, 2. D is -3, 0. So CD is equal to square root of -3 minus of minus. This is plus 1 whole square plus 0 minus 2 whole square. So this CD is equal to root of -2 whole square plus -2 whole square. That means 4 plus 4 again. -2 whole square is 4. Here -2 whole square is also 4. That means 4 plus 4 is root 8. That is this CD is also equal to 2 times root 2. CD is also over. And finally AD. So what is A? -1, -2. And D is -3, 0. So what is AD, students? AD is equal to root of -3. Here it is minus. So minus into minus plus 1 whole square plus 0 minus of -2 is plus 2 whole square. So this is -2 whole square. 0 plus 2 is also 2 whole square. So this is also 4 plus 4, that is root 8. That means that is equal to 2 root 2. So now we have a doubt here. Why AB, BC, CD, AD, all the 4 sides are equal here. AB is equal to BC is equal to CD is equal to AD. Now we have a big doubt. What? These vertices are the vertices of a what? Rhombus or square. Rhombus means the diagonals are not equal, but coming to the square, the diagonals are equal. So my dear students, let us find the lengths of the diagonals. AC and BD. What is A? -1, -2 and C is -1, 2. This is C. So AC is equal to root of -1. Here it is -1 is there. So minus into minus plus 1 whole square plus 2 minus of minus plus 2 whole square. -1 plus 1 is 0. 0. 2 plus 2 is 4. 4 square means that is equal to 4. So AC is equal to 4 units. Coming to this BD, B is what? What are the vertex? What is the vertex of B? 1, 0 and D is -3, 0. So this BD is equal to root of -3 minus 1 whole square plus 0 minus 0 is 0. So we no need to write that one. -3 minus 1 means -4 whole square. So this is -4 whole square under root. So here this BD is equal to root of 16, it is equal to 4. So my dear students, here AC and BD are equal. Did you observe here? What do you observe here? All the four sides are equal and the diagonals are equal. Therefore, what do you say about this quadrilateral ABCD? So therefore, ABCD is a square. ABCD is a square. Why it is a square? All the four sides are equal, and the next point is the diagonals are also equal. So ABCD is a square. Okay, coming to the 10th question. This is very important for AP board students. Find the point on x-axis which is equidistant from 2, -5 and -2, 9. The same type of question we have an example also. Example 9. Find the point on y-axis which is equidistant from both the points capital A 6, 5 and -4, 3. So there in the example we have to find the point on y-axis. Here we have to find the point on x-axis. So my dear students, here point on x-axis I already explained in the first video in this coordinate geometry. Point on x-axis means that y coordinate is equal to 0. So the y coordinate is equal to 0. That means x, 0. Let it be x, 0. Suppose to find the point on y-axis, that y-axis, that x coordinate is 0. That means let it be 0, y. Okay. So to take the point on x-axis means take the y coordinate as 0. So for example, let it be x, 0. Point on x-axis, y coordinate is 0. Okay. So now my dear students, here what we have to find here, point on x-axis. That means let the point on x-axis be x, 0. Here this is y coordinate, that is equal to 0. Okay, this x, 0 is equidistant from 2, -5 and -2, 9. This is -2, 9. Okay. So this point is equidistant from this 2, -5 and -2, 9. So my dear students, here, so here let us find the distance between x, 0 to 2, -5 and x, 0 to -2, 9. Okay. See what is given. This point on x-axis is equidistant from 2, -5 and -2, 9. That means the distance between x, 0 to 2, -5 is equal to the distance between x, 0 to what? -2, 9. Okay. So first to take x, 0 and 2, -5. Here x, 0 and -2, 9. Let us find the distance between these 2 points. Similarly, find the distance between these 2 points. Okay. So what is distance formula? Root of x2 minus x1 whole square plus y2 minus y1 whole square. That is equal to 2 minus x whole square plus -5 minus 0 whole square. So 2 minus x whole square, square root of 2 minus x whole square, -5 minus 0 means -5 whole square, that is plus 25. -5 minus 0 is -5. -5 whole square is plus 25. Okay, similarly here this is -2 minus x. x2 minus x1 whole square plus y2 minus y1, that means 9 minus 0 whole square. So minus 2 minus x whole square means just it is 2 plus x whole square plus 9 minus 0 whole square is 9 square, that is 81. Okay, so according to the problem, no need of writing here, already written no here. So according to the problem, root of 2 minus x whole square plus 25 is equal to root of 2 plus x whole square plus 81. Okay, now to remove the square roots on both sides, just squaring on both sides here, squaring on both sides, that means root of 2 minus x whole square plus 25 whole square is equal to, this is implies, is equal to root of 2 plus x whole square plus 81 whole square. Now square root get cancelled. So this is implies 2 minus x whole square means let us expand using a minus b whole square. You know the a minus b whole square. What is a minus b whole square, students? A square plus b square minus 2ab. Here this is in the form of a plus b whole square, that means a square plus b square plus 2ab. So this is implies 2 square plus x square minus 2 into x, a square plus b square minus 2ab. Here it is plus 25. So this is equal to, again using a plus b whole square, 2 square plus x square plus 2 into x plus 81. Okay. See my dear students, here now if you observe both sides, plus 2 square get cancelled, plus x square plus x square also cancelled. Finally, what is in the left hand side here? Minus 4x. This plus 4x, when it transposed to this side, again minus 4x. So here plus 25, when this plus 81 comes to this side, minus 81, so it is equal to 0. So this is implies minus 8x plus 81 minus 25. Let us subtract here. 11 minus 5 is 6, 7 minus 2 is 5. So this is what? Minus 56. This is equal to 0. So my dear students, here minus 8x is equal to plus 56. X is equal to 56 by minus 8. So x is equal to 7 times it get cancelled. That means x is equal to minus 7. Therefore, what is the point on x-axis? X comma 0. So value of x is minus 7. Therefore, the point on x-axis is minus 7 comma 0. Minus 7 comma zeros. So it is an important sum for the public examination. Okay. Did you understand this question's answers, students? Okay, please write down. Coming to the 11th question in this exercise 7.1. If the distance between 2 points x comma 7 and 1 comma 15 is 10, find x. Okay. See here, it's already given that the distance between x comma 7 and 1 comma 5. Sorry, 1 comma 15. It is 1 comma 15. Given that the distance between x comma 7 and 1 comma 15 is 10. That means take x comma 7, this is solution. Take x comma 7 and 1 comma 15. This distance is already given, that value is 10. That means this is x1, y1, x2, y2. So let us take the distance formula here. x2 minus x1, that means 1 minus x whole square plus 15 minus 7 whole square. This is equal to 10 units. See my dear students, here this is implies, look here, 1 minus x whole square plus 15 minus 7 is 8 square is equal to 10. Let us squaring on both sides to remove the square root here. Again squaring on both sides like a previous sum. So that means if you squaring on both sides, this is 1 minus x whole square. 8 square is 64 is equal to 10 square. Here also whole square. Now the square and root get cancelled. So this is 1 minus x whole square plus 64 is equal to 10 square is 100. This 10 square is 10 into 10, that is equal to 100. Implies 1 minus x whole square is equal to 100 minus 64. Just transpose that plus 64 to other side. So this is 1 minus x whole square. 100 minus 64 is 36. So this 1 minus x is equal to square root of 36. So this 1 minus x is equal to plus or minus 6. The square root of 36 is plus or minus 6. So 1 minus x is plus 6, one case. 1 minus x is equal to minus 6, another case. So this minus x is equal to 6 minus 1. So minus x is equal to 5. So x is equal to minus 5. Now similarly here this minus x is equal to, just transpose this plus 1 to other side, that means minus 6 minus 1. So minus x is minus 1. So x is equal to 7. Therefore the values of x are here, one is minus 5 and another one is plus 7. Coming to the 13th question, before we get into the 13th question, here my dear students, the 12th question just I am leaving here. Find the value of y for which the distance between 2 comma minus 3 and q 10 comma y is 10 units. It is like just before previous sum, 11th sum, same model only. You can try it, this sum. Okay. Now we will try this 11th question. We will solve this, 13th question. Find the radius of the circle whose center is 3 comma 2. So just take a circle. Here this center is at 3 comma 2. This center is at 3 comma 2. Okay. And passes through minus 5 comma 6. This circle is passes through minus 5 comma 6. This is center and this is a point A. So what is OA? The distance between center to any point on the circle is called radius. So the radius is equal to OA, the distance between the center to any point on the circle. Okay, what is O here? 3 comma 2 and A is minus 5 comma 6. That means this OA is equal to, it is nothing but radius is minus 5 minus 3 whole square. That means x2 minus x1 whole square plus y2 minus y1. That means 6 minus 2 whole square. See, as I told you, the whole exercise we from the first sum onwards we have been using the distance formula only. Okay, so this is equal to minus 5 minus 3 is minus 8 whole square plus 6 minus 2 whole square means 4 square. So this is 64 plus 4 square is 16. Okay, minus 5 minus 3 is minus 8. Minus 8 whole square is 64. 6 minus 2 is 4 square. 4 square is 16. Okay, so 64 plus 16 is root of what? 80. So this 80 can be written as 16 5s are 80. 16 into 5 is 80. So what is the square root of 16? So that is 4 and this is root 5. So this radius is equal to what? 4 into root 5 units. Coming to the 14th question, my dear students, can you draw a triangle with vertices 1 comma 5, 5 comma 8, 13 comma 14? Give reasons. Just I will give you small clue here. 1 comma 5, 5 comma 8, 13 comma 14. Okay. When can you draw a triangle? When the three vertices are given. See, we must learn the properties of a triangle. To solve this question, 14th question, we have to learn the properties of a triangle. What are the properties of a triangle? The sum of any two sides of a triangle is greater than the third side. The first property is the sum of any two sides of a triangle is greater than the third side. And the second property is the difference of any two sides of a triangle is less than the third side. Okay. See here, the three vertices are given A, B, C. To prove whether we construct or whether we draw a triangle using these three vertices or not means, see my dear students, observe here, please listen carefully. We should find the distance between AB, BC and AC. Just I am leaving this sum for you. You can do this. We already done few problems in the same model only. Okay. See, just find the distance between AB, BC and AC. If the sum of any two sides is greater than the third side, that means AB plus BC is greater than AC, it must be like that. BC plus AC must be greater than AB and AB plus AC must be greater than BC. Then we can construct a triangle using these three vertices. The second property is not required. If the first property is satisfies, then you can construct a triangle. Did you understand, students? What is the first property? I told you. The sum of any two sides of a triangle is greater than the third side. That means this AB plus BC, just I am writing here, AB plus BC must be greater than AC and BC plus AC must be greater than AB and AB plus what? AC must be greater than BC. Then only we can construct a triangle. Otherwise, it is not possible to construct a triangle. Okay, understood, students? That means just simply you find the distance between AB, BC and AC and verify these properties, these inequalities. That means the sum of any two sides must be greater than the third side. Can you do this, some students? Okay. Now we come to the last question in this exercise 7.1. Last question. It's very important sum for the public examinations. Okay. It's an important question. Find a relation between x and y such that the point x comma y is equidistant from -2, 8 and -3, -5. This is similar to the point on x-axis. Or example, find the point on y-axis which is equidistant from so and so, like that. It is like the example sum and 10th question. Okay. Now look here, students. This x comma y is equidistant from -2, 8 and -3, -5. This x comma y is equidistant from -2, 8 and this x comma y is equidistant from -3, -5. That means x comma y -2, 8, x comma y -3, -5. Find the distance between these 2 points. Again, find the distance between these 2 points here. So let us use the distance between 2 points formula again. Here, my dear students, total 15 questions are here. All in 15 questions we have been using only the distance formula. Okay. So this is root of x2 minus x1, that means -2 minus x whole square plus y2 minus y1, that means 8 minus y whole square. Even here also this is square root of -3 minus x whole square, that means x2 minus x1, where x2 is -3 and x1 is x, plus y2 minus y1, that means -5 minus y whole square. Okay. See, if you observe here, this minus 2 minus x means if you take minus s common, it will become 2 plus x, that means whole square, plus 8 minus y whole square. See, even here also minus 3 minus x means if you take minus s common, that is 3 plus x whole square. Here also same, minus 5 minus y, that means 5 plus y whole square. So according to the problem, the distance between x comma y2 minus 2 comma 8 and x comma y2 minus 3 comma minus 5 are equal. That means, look here, according to the problem, here this square root of 2 plus x whole square plus 8 minus y whole square is equal to, this is 8, is equal to square root of 3 plus x whole square plus 5 plus y whole square. Okay, now squaring on both sides, we can remove the square roots. To remove the square roots, just I am doing squaring on both sides. That means 2 plus x whole square plus 8 minus y whole square is equal to 3 plus x whole square plus 5 plus y whole square. Okay, now let us expand using a plus b whole square, a plus b whole square, but here we should use a minus b whole square, but here and here we use only a plus b whole square. Okay, so this is implies, what is a plus b whole square? A square plus b square plus 2ab. A minus b whole square here means a square plus b square minus 2ab. So here this is a b. 2 square means 4 plus x square plus 2 into x. 2ab. 2 into x means 4x. Similarly here 8 square is 64 plus b square means y square minus 2ab means 2 into 8 into y, that means 16y. It is equal to, again, 3 plus x whole square. See, it is in the form of a plus b whole square. That means 3 square is 9 plus x square plus 2ab means 2 into 3 into x. 2 3s are 6, 6 into x, 6x. Plus, just you again expand 5 plus y whole square. That means 5 square is 25, b square means y square plus 2ab means 2 into 5 into y. That means 2 5s are 10y. Okay. Now just observe the two sides, students, left hand side and right hand side. Here this plus x square get cancelled, plus y square also cancelled. Okay. Finally, what is here? Plus 4 plus 4x plus 64 minus 16y. So what is plus 4 plus 64? That is plus 68. Plus 4 plus 64 is plus 68. So here plus 4x minus 16y, it is equal to, now coming to this side, right hand side, 9 plus 25 is 34. Next plus 6x plus 10y. Okay, this is right hand side. Now just let us collect the all what variables to left hand side, and we just transpose that numerals, numbers to right hand side. That means 4x minus 6x minus 16y minus 10y is equal to 34. Just transpose this plus 68 to other side, that is minus 68. So this is implies 4x minus 6x is minus 2x, minus 16y minus 10y is minus 26y, 34 minus 68 is minus 34. Okay. Now my dear students, if you take minus 2 as common on the left hand side, then x plus 13y will be there. Here also just take minus 2, this minus 34 just written in the product as minus 2 times 17. So here this minus 2 get cancelled. Finally, this x plus 13y is equal to 17. So my dear students, this is the relation between x and y. Okay, this x comma y is equidistant from minus 2 comma 8 and minus 3 minus 5. Then the relation is x x plus 13y is equal to 17. I hope you understand all these first exercise questions from first question to 15th question. See, my dear students, this whole exercise, the main formula we use here is only distance between 2 points. The next exercise, that means 7.2, we use section formula. In the coming video, just I am going to upload the proof of section formula. Don't miss that second exercise. See, if you really like my videos, please like, share and subscribe my channel. Don't forget to write in the comment box. Thank you very much. Thanks for watching. Thank you.